It's Mr. Ring going over the Algebra 2A quiz number 18, March 12, 2015. The quiz was out of 72 points. Question 1, factor completely, 40x minus 10. If you write out all your factors there, notice that your GCF there is a 10. You got 10 times quantity 4x minus 1, which is choice B. Also in this problem, you'll recognize that because it's only to the power of 1, it's linear, you can actually take out a GCF, and let's just say you can actually use X box. Your A is 0, B is 40, and C is negative 10. A times C, this is your B value, two numbers that multiply to be 0, but add to be 40, that's 40 and 0. 0x squared and negative 10 is your last term. Then you put 0x and 40x. This will be 4 times 0x. 4x times 10 gives you 40x. 0 times negative 1 is 0x, and negative 1 times 10 gives you negative 10. So then your factors are just 4x minus 1 and 0x plus 10 are just 10. Question number 2, write them out, the GCFs. You notice that they have the x to the 4th and the 2. So those values right there, I'm writing in the very front. Then I'm just left with x squared minus 6. And your answer is C. Question number 3, factor completely. Just did A times C, which is negative 15. B value is 2. These multiply to be negative 15. Those same two numbers add to be positive 2. Because A is equal to 1, you can just do 5 and negative 3 as our answer, so letter choice A. Question number 4, factor completely, x squared minus x minus 54. Your A times C is negative 54. Your B value is negative 1. To help me, I can list out all the factors of 54. Ignore the negatives, so it's 54 and 1, 27 and 2, 18 and 3, 9 and 6. And I can't think of these two numbers to either add or subtract to be negative 1. I can figure out that they'll multiply to be negative 54, but they won't add to be negative 1. So the answer is prime. Question number 5, factor completely. This is z squared minus 16. Essentially, A times C is negative 16. Your B value is 0. The two numbers are positive 4 and negative 4. Those are essentially your factors. Remember, you don't have to use the box when A is equal to 1, but you can. It's not wrong. So my first term, z squared, negative 16. Then what you put in the box here, 4z and negative 4z. So I have z times z gives me z squared. Z times something, that something is negative 4. Z times something, that'd be positive 4, gives you 4z, and positive 4 and negative 4 equals negative 16. So then my answers are z minus 4 and z plus 4. Question number 6, factor completely. I have 3y squared. 15y squared plus 16y plus 4. A is 15, C is 4, so I multiply those two to get this. This is A times C. Your B value is 16. I wrote out all the factors of 60 to help me figure out which two numbers. Something I didn't list. Oh, there it is. 6 times 10. 6 and 10 will give me 60, but I add them together equals 16. So here, remember, A is greater than 1, so you must use the box. Remember, if you get stuck regardless, always use X box. When you see the directions, factor completely. So now I take the 6 and the 10. I write it here, 6y and 10y. This is your first term, 15y squared, and positive 4 goes in the last box. Two terms that multiply to be 15y squared, that's 5y and 3y. 5y times 2 gives me 10y, so I write 2 there. And 3y times 2, write 2 there, gives you 6y. Double check, then gives positive 4. So my answer is 3y plus 2 and 5y plus 2. Remember, if you got every single question correct on page number 1, and give 2 points extra credit. Question number 7, should have factored completely. I mean, you're taking out your GCF, that would have been negative 2x. It essentially gives you A value of 25, B is 5, and C is negative 6. That gives you negative 150. Do two numbers that multiply to be negative 150 are 15 and negative 10. Those add to be positive 5. Now you're just going to take those two values and put them in the box just like this. Remember, add x there. This is your first term. Remember, don't include the negative 2x or that negative 50. You factored it out, and now you're just focusing what's in parentheses. Last term, negative 6. This will give you 5x, and 5x gives you 25x squared. 5x times negative 2 gives me negative 10x, so that's how I got the negative 2. 5x times something will equal 15x, that's 3x, and that double checks. Those are my terms, 5x minus 2 and 5x plus 3. Don't forget the negative 2x as your GCF. Question number 8, it has a second variable, so I kind of circled that second variable, the v, and just write it without the v. Do your regular problem. Here's my x box, negative 5 and 8, and you'll get u minus 5 and u plus 8. Now notice how the u's are on the left side, and then my v's are on the right. So that's when I go back and add the v to the right side of my binomials. Question number 9, factor completely. Take out a GCF, and then you factor this, you'll get x minus 3x plus 7. Remember, I'm going to show in this problem that math is very forgiving, so a is 2. Let's just say you don't take the GCF. You'll still recognize you can still do the problem. A times c is negative 24. B value is negative 2. Two numbers that multiply to be 24 but add to be negative 2, so that's 4 and 6. This one will have to be negative, so that when you add them it gets negative 2. I'm not going to stop there because a is greater than 1. So I have 2x squared minus 12, 4x, negative 6x. Let's try 2x here, and x here, so 2x times, that would be a negative 3, x times 4. So essentially you'll get 2x plus 4 and x minus 3. Well, if you recognize in this problem right here, the reason why this wouldn't be one of your answer choices, actually it is, that's the major distractor, is that you need to take a GCF of another 2. That would give you 2 times quantity x plus 2, x minus 3. Question number 10, factor completely. My GCF is an x, and then you just factor that using your x box or snowflake. Question number 11, factor completely. Remember, you can write this as x squared plus 0x minus 4. Essentially missing that b term, your b is 0. This is also a difference of squares, so let me show you another way of solving a difference of squares. Difference of squares is difference, that's the subtraction. That means one will be positive, one will be negative. And then if you can take the square root of both of these. The square root of x squared is just x, or that they essentially cancel. And the square root of 4 is 2. X plus 2, x minus 2. Question number 12, you need to be careful to write that in descending order. That would be x squared plus 4x plus 3, and then you can just factor. So just be careful in this problem. A is not 4, A is 1. Question number 13, a little bit difficult to see. Tell whether the lines for each pair of equations are parallel, perpendicular, or neither. Just transform both of those into slope-intercept form. Notice my slope. They're not equal to each other, so they're not parallel. Parallel slopes are equal, so it's not that one. Perpendicular is that their slopes product is negative 1. So if I multiply these two numbers, I'll get 7 over 16. So it's not perpendicular, therefore it's neither. Neither is my answer. Question number 12, tell whether the system has no solution. So no solution means it's parallel. One solution means it's intersecting or perpendicular. And infinitely many solutions means it's the same line, coinciding lines. I notice my slope is the same, but my y-intercepts are different. That means it's parallel. You can also graph those and recognize that that's the case. That's negative 4, negative 5, and they'll be parallel. So therefore it's no solutions. Question number 15. Which statement best describes a method that can be used to sketch the graph? Y equals absolute value of x plus 1. So what you can do is you can compare that to the parent graph, y equals absolute value of x. And I'm going to write x plus 1 here with a minus sign, x minus negative 1. The reason why I want that is because in my equation, it clearly shows here x minus h. There must be an x and there must be a minus, therefore h is equal to negative 1, and your k value is 0. This gives me the vertex. This is the vertex form of absolute values, so negative 1, 0. So this is my graph right there, and your parent graph there is in green. And you'll notice how I'm going from the green to the pink. I'm moving it over 1 unit. 16, same thing here. Write it in vertex form. K is negative 2. So you'll notice how the parent graph is here. And your pink graph with a vertex of 0, negative 2 is down here. Therefore, it's moved down 2. That's essentially your constant. That's your y-intercept movement. Question number 17. Solve the system of equations algebraically. I decided to multiply by negative 1 because I realized these are the same, but I want them to be opposites. Distribute the negative 1 all the way through. Add down, you'll get 3. Positive y, that equals 0. I've done elimination essentially. Put in y equals 3 in any equation. I pick the top one. That says negative 9. And 9 on both sides, divided by 5, x equals 3. 3 is my solution. Question number 18, compare the graphs of the pair of functions. Describe how the graph of the second function relates to the graph of the first. So I have y equals negative 2 absolute value of x, and y equals negative 2 times absolute value of x minus 3. So essentially the only thing that's different here is this minus 3. So what does that do? It just moves your graph down negative 3 units. That's your k value. Question number 19. I have a horizontal parabola, which we haven't talked about yet, but from the graphs you should be able to determine the domain and range. So domain essentially means going from left to right. So at left, this is the first thing I touch, which is negative 4, and my values keep going, and the last thing I touch is the arrows, which means I keep going with all of these numbers. If you had 2 sets of arrowheads, meaning over here, that would have been all the negatives and all the positives. But here I have all the positives, which means I need big numbers that are bigger than negative 4, or x is greater than or equal to negative 4. Notice how we're talking about the domain, which is the x-axis, and that's why I have the x variable. On the range here, you're going from bottom to top. So the first thing you touch is the arrow, and the last thing you touch is the arrow. So it's all these negative numbers, all these positive numbers. That means it's all real numbers. Should be up here. Now in interval notation, you're starting at negative 4. Remember, that's assuming that's like a closed circle, that's a solution. So this would be bracket negative 4, meaning that's including, that's the equal sign, and I'm going towards infinity. The range, again, from bottom to top. First thing you touch is the arrow, which is negative infinity, and go up. That'll be positive infinity, negative infinity, positive infinity. Those should be synonymous. Question number 20. Factor completely. I noticed that I can factor out an x to the 3rd power. That's my y here. And I notice that I look at my coefficients and I can also take out a negative 3. The reason why I want to take out a negative 3 and not just a positive 3 is because if you write this in descending order, the x to the 4th power comes up first, and you don't want that to be negative. So you'll get negative 3x to the 3rd times quantity x minus times quantity x to the 4th minus 3xy minus 2. Remember, you can take this value and distribute to each of the terms and double check your answer. You'll notice that you can't factor this. Number one, it's not quadratic, so the power of 2. Second thing we realize you can't factor is because my exponent here isn't half. Half of 4 would be 2, so you would have to have a 2 there. And the third thing is that I have an extra variable here, that's the y variable. Question number 21. I'm going to distribute the 1/2, or instead of distributing, I can just get rid of this by multiplying both sides by 2. 2's will cancel. You have 4x plus 5 equals 4x plus 5. Subtract 4x from both sides, you get 5 equals 5. 5 equals 5 all of the time. So all the solutions, all real solutions. All real numbers. Question number 22, solve the system. I noticed that if I write these, x minus 5, what did I do? Multiply by 2. X minus, okay, so what's different is that the x's and y's aren't aligned. So if I aligned them, I would have negative y and positive x. Well, I decided to make my x's cancel. So I took the first equation and multiplied by 2, and you get this. Now when I add down, these will be eliminated, and you're left with just y equals 2. Take y equals 2 into an equation, and you get x equals 3. 3 negative 2 is your solution. Question number 23 has been on the same quiz. 2 weeks in a row, explain why the inequality 3 is less than x, less than 1 has no solution. So I think a lot of students can improve in their explanations. I gave you 2 points if you got this graph here. 3 points if you're going the right direction. So you need a number. Notice how this compound inequality, when you graph it, should look like oars on a boat, right, going away from each other, but this shows the word and. So I need a number that's less than 1, and also greater than 3. Well, I can't find a number. There's no number that's both smaller than 1, but bigger than 3. That's impossible. There's no number. Number 24. Graph, make sure your intercepts are labeled. I have an equation in a not so standard form. I subtracted 3x, negative 1/3 x to both sides. I want to get rid of this negative 2, so instead of dividing by negative 2, dividing by negative 2 is the same thing as multiplying by negative 1/2. Multiply by negative 1/2. These will cancel, you're left with y. Here I need to distribute this negative half. Negative times negative is a positive. Multiply the numerators and denominators. You get 1/6x. Negative times negative is a positive, and this becomes 3/2. So a lot of students were like, if you got this far with no graph, I gave you 2 points out of 4. 1/6x is my slope, and 3/2 is my y-intercept. 3 divided by 2 is essentially 1.5. So you should think it's between 2 and 3, not between 2 and 3. Between 1 and 2, 1.5. There it is. I don't have enough graph to show that my x-intercept is negative 9. So let's just say you graphed all of this correctly without labeling your intercepts. I gave you 3 out of 4. Question number 25. 4/5 minus 5/6. I can't subtract 4 minus 5, and I can't subtract 5 minus 6. The reason why is in fractions you need to have a common denominator. The least common denominator is 30, so to get to 30, I multiply the left side by 6/6. Or not multiplying by 6. That would give me 24 and 30. This side I'll have to multiply by 5/5 to get me a 25/30. Notice I have a common denominator. Now I just subtract the numerator. 24 minus 25 is a negative 1. Negative 1/30 is my answer. Question number 26, same question from last week. You're graphing this piecewise function. Let's make sure you label the intercepts and endpoints of the piecewise function. So g of x equals. So when you have this equal sign, that essentially tells us that all of the lines will be solid. Because of this equal sign, all of them are solid. The confused student thinks, well, Mr. Ng, I have inequalities here. So number 1, can I shade? No, don't shade, because shading is implied when this one here, with that function of the name, is an inequality. Okay. Then you might think, well, Mr. Ng, should it be solid or dashed? Again, if this was less than or equals to, then that would indicate maybe shading or solid lines. But in this case, it's essentially the constraints. Your constraints of your graph are telling you that they should only be in this location. So it says g of x equals 3. Well, remember, g of x could be written as y, and y equals 3 essentially means all your y values are 3, make up your x values. You'll notice how it's a horizontal line at y is 3. Well, it tells you x is less than or equal to 0. Only draw the graph where x is less than or equal to 0. So the numbers are the same, and that's essentially a vertical line, and you need numbers starting there but are smaller than us to the left. So close circle because it's less than. Where it says g of x equals x, this essentially means g of x turns into a y, and you might need to add 1s and 0s to help you in that slope-intercept form. Start at the origin, go up 1, right 1, the slope of 1. And the reason why I'm only here in quadrant 1 is because I need values that are greater than 0. Greater than means open circle. My endpoints are 0, 3, and 0, 0. Essentially graded if you got 2 points per an equation. If you graph, let's just say a horizontal line, to give you 1 point, and let's say graph that whole line, it's another point. Question number 27, 4x squared plus 1. Let's just say you did a times c is 4, b is 0. You need two numbers that multiply to be 4, but add to be 0. And this is impossible, it doesn't work. So the answer is prime. If you wrote the words can't be factored or can't factor, non-factorable, I gave you only 3 out of 4. The correct answer we're looking for is prime factorization. Question number 28 wasn't a trick question. I meant to write x squared minus 10x plus 16. So if you thought this was x squared minus 10x plus 16, and you factor it, you should have gone x minus 8, x minus 2. The real problem, though, next week it won't be extra credit. X squared plus 16, because you're just adding negative 10 and 16, gives you x squared plus 6. So x squared plus 6, that's prime. That's prime. Question number 29, factor out GCF. I have 3x squared minus 5x plus 2. You should see if that's factorable. Excuse me, as a trinomial. A times c, my b value. Two numbers that multiply to be 6, negative 2 and negative 3. Then I'm putting those into my box. First term, last term. These multiply, therefore I get x minus 1 and 3x minus 2. Now don't forget that GCF of an x here. If you missed this GCF, you didn't put the x there, I subtracted a point. If you just did the x here and you thought it was x minus 2, x minus 3, I give you 2 points as well. Hopefully that was helpful for your quiz corrections. You won't make those same errors on next week's quiz and the chapter test. Thanks for watching.